I have a question about the universality thesis of this kind of observer that we are, or of machine learning algorithms. Can you explain this universality hypothesis? And do you think the human mind is, in a way, this kind of universal function approximator?
There is a version of the universality hypothesis that has been put forth by Chris Olah and others who work in a group at OpenAI. And their hypothesis is that if you take something like a neural network or a learning system that makes sense of the world, for instance, visual data, and you connect it to the same world, the thing is sufficiently unconstrained in the way in which it learns, so it builds a near optimal model, then the model is going to have pretty much the same structure, regardless of the architecture that you're building it in. So basically, if you take different neural networks and you connect them to the same types of cameras in the same type of environment, you're going to end up with basically equivalent feature hierarchies. And I think this is the flip side of the good regulator theorem by Cordell and Ashby. If you have a system that regulates something, then it needs to implement a model of what it regulates. It is isomorphic to the dynamics of what you're regulating. Otherwise, you cannot regulate it well. So if you optimize the regulation and you give the system enough freedom to conquer enough of the space, then it's going to find a structure that is modeling the dynamics in a particular way, and the different system is going to do the same thing. We find also empirically, when we look at the way in which we model the world, that we do have differences. And the differences are rare, but for instance, you might decide to, or your brain might decide at some level, to model a sound using absolute pitch or relative pitch. These are two different implementations of a classifier for pitch. Right? When you, like most people, interpret music using relative pitch, it means that your mind is using a local based note, and then you are comparing everything to this local based tone. So it's a relative representation of the sound in the local context. Whereas this absolute pitch is using an absolute oscillator that is tuned independently of what you're hearing right now and compares everything to that absolute oscillator. And you can entrain your brain with both for interpreting sound. Right, both work. And they have slightly different outcomes, but the data that we get from our environment usually don't get relative pitch listeners to switch back or switch over to absolute pitch unless you give them very specific training. And it's difficult in adults because you have to overcome limitations in neuroplasticity, which subjectively means you have difficulty to get attention into the level of sound processing where it would be necessary to make the change to switch from relative pitch to absolute pitch. And similar things happen in facial recognition and facial perception when you are trying to find prototypes to interpret faces. This depends on the faces that you've seen before. And so when you grow up in different cultures, then different faces look similar to you or dissimilar to you than for other people. Or color categories are the result of an interplay between the colors that you're being taught to classify as a child and the color cones that your particular eye has. So if you're colorblind, of course, you're going to end up with different color perception, and the internal mathematics of the color perception. Because once you make a commitment that this is a certain color and a certain vector in the space of colors, then this has influences on the other vectors of colors in that space of colors. I don't think that we have a complete optimal learning theory yet that describes how much data you should, or how much you should update given a certain model beyond Bayesianism. So we have the beginnings of the mathematics for doing that using Bayesian mathematics, but I don't think that most of machine learning is driven by a systematic approach yet, where we think of designing an optimal curriculum from which you take the optimal amount of information to train your system in an optimal way. There is, on the other hand, the no free lunch theorem and so on that suggests that if you are thrown into an arbitrary universe and you start out with some kind of learning system, you can in principle not figure out the ground truths. That's because you don't have enough baselines or enough constraints to learn everything about the world. But there is something that constrains us, and that is the fact that the universe must contain the conditions to to accommodate you. Somehow the universe is built in such a way that we can exist in it. And this constrains the universe in many, many ways. And this makes it learnable. The universe that we observe is a controllable universe because in some sense, every structure that we are part of is a part of a hierarchy of control. The molecules are controlling atoms in a way. Atoms are the result of the control of elementary particles. Cells are the result of the control of molecules. Organisms are the result of the control of cells. And societies are the result of the control of individuals. And as a result, you basically get a world that can be modeled by controllers. It's a hierarchy of controllers, and therefore it's a learnable hierarchy. And those things that are uncontrolled are stuff that we cannot learn. There's stuff that looks like noise to us. And there is stuff that looks like noise to us, lots of it, right? We mostly ignore it because it's just noise. But once something is controlled, it seems to be learnable.
So if I understand you correctly, there's no kind of optimal algorithm or Solomonov induction that works for every conceivable, every constructible universe, because because there will always be data that doesn't affect us, that doesn't constrain our existence.
That might also be true, but then there's the question: how is the universe constructed? And it could be that the set of possible functions that could construct a universe like ours and that don't exceed a certain length is limited, right? And as a result, if you could just iterate over all those functions, when you discover the space of such functions, you might stumble on the basic formula that would be able to produce a universe like ours. That's used to be Wolfram's hypothesis and program. Maybe it still is. His idea was, instead of trying to reverse engineer the world with an ever more complicated theory of physics that you then try to unify and simplify until it explains everything, including the standard model and all the interactions in the world that we are observing, go from the other side, basically try to iterate over the possible set of generator functions for the universe, all the standard models that could exist in a way, and see if one of them generates a universe like ours.
So this would be like the rational mathematical deduction or iteration of all possible universes, and then kind of the comparison of one of those models with the dynamic that we face.
But it's not clear if this thing is going to be successful, because, for instance, the issue of computational irreducibility, to figure out if something turns out into a universe like ours, maybe you need to calculate very, very far. So you won't have the resources to do anything that goes at any depth beyond the Big Bang, right? So you're not going to see how the universe plays out. It doesn't mean that the hypothesis is wrong. It's just not obvious whether it's possible to go about this way. Also, maybe the universe isn't simple. Maybe the universe is everything. So maybe the universe is the entirety of all automata interacting in a certain way. And we are just in a very small region of that possible space. How are you going to discover the solution to that? So that's very tricky. And there is also this big difficulty that I don't know how to get a handle on, answering the question whether it's something rather than nothing. There are few promising attempts, I think, to answer that question, and nothing that is canonical. And the thing that I find most plausible is that maybe existence is the default. So all the things that can possibly exist, which means that can be possibly implemented, somehow do exist. That would allow you to explain why something exists at all, because basically everything exists. And it's still counterintuitive that stuff would exist by default. But this says something about the structure of my mind, what I find intuitive. It obviously doesn't say something about the structure of reality itself. And it's difficult for me to square that.